Hi guys, Mr. Lead here. Sorry I couldn't be here in person, but nevertheless, we'll press on. Today we're going to be looking at microscopes, and it's my hope that by the end of this lesson, you'll be completely knowledgeable about microscopes, ready to use them next lesson. Now, you should have some sheets with PowerPoint slides on them, and they'll have lots of blanks. As we go through these slides here, make sure you fill in the blanks on your sheets. And if you can't keep up, don't worry, you can go back and look at these PowerPoint slides on Sector. Nevertheless, let's keep going. So as I said, today we're going to be looking at microscopes. It's my intention that by the end of this lesson, you'll know you'll know how a microscope works, the different parts of a microscope, what is magnification and how you calculate magnification, and you also know what are the different types of microscopes. So starting with what is a microscope? That's a simple enough question. It's a device that we use to see things close up. But the way we use this is we have a stage down here where we put our specimen that we're observing. So this is where we're putting our specimen. And underneath, we need a light source, because if you were to look at something close up without that light source, it would be too dim for us to see anything. Our microscope also comes with two lenses here. Now, microscopes generally, they can either be monocular or binocular, which literally just means one eye or two eyes. As for parts of a microscope, now this is really key for you guys to know before you start handling a microscope. With your microscope, you're going to have an eyepiece and an objective lens. So like I said, there are two lenses for your microscope. This one is pretty much fixed. You're stuck with this lens, but this one you can turn around to get different sizes of magnification. This is the stage where you're going to put on a little glass slide where you're going to have your specimen. Underneath is going to be the mirror or the lamp. And then we've got two levels of focus. What these do is they raise or lower the stage so that what you're viewing will either be blurry or in focus. And this one over here makes sure it lowers the stage just a little bit, so you're controlling things a lot more finely. And this one raises it a lot. Actually, I think I got it the other way around, but you get the idea. Last thing to note, this is the handle. When you're carrying a microscope, I've actually got my own microscope as an example. When you are carrying a microscope, you need to be holding it by the base and the handle here like this, okay? So come time when you're using them, this is how you use them. All right, cool. Now, in class, we're going to be using two types of microscopes. Firstly, there is the stereo microscope. So this one's a bit different to the one before I showed you, because this one doesn't need a little glass slide. To show you what I mean by a little glass slide, here I'll show you the one on this microscope here. Here's a glass slide. You have a cover slip on top where you got the specimen underneath. It's really dusty, this one. And then you got the slide. But with stereo microscopes, you don't need a slide, which means that you can actually handle the specimens with your hands underneath. You can dissect them while you're viewing under the microscope. You can do a lot of different things. Stereo microscopes, though, are only good for, they're good because you can put a large object under there as opposed to a small little object. But you don't get to zoom up very far on them. Now, it's important to know the differences between these microscopes as I go. Whereas the normal microscope, the monocular, binocular microscope, that's got a much higher magnification. See, we can magnify something up to 1,000 times instead of 100 times, but it has to be a small specimen. Okay, well, now let's just briefly go over how exactly does a microscope work? How exactly are you seeing what you are seeing? So, like I said before, you have a light source. Okay, actually, no, I'll go back to this image. So when we've got light coming through, that light is coming through down here and it's going to be passed through that that specimen so that it's illuminated, and then it comes up to reach your eye. So imagine if the light source was on the side instead. The animation's a little dodgy here, but yeah, the light comes up so that we can see it. Now, like I said before, a microscope can come with an objective lens that can be turned around like this. So you can actually get different sizes of magnification. To calculate that magnification, you can see on your microscope that remember we have two lenses. This one says it magnifies by 10. Okay, so that's what the 10 is. Ignore the other symbols, just the 10. And on here, you'll see we've also got, let's see if I don't think I can show on the camera. On each of these, here it is. On each of these different numbers here, on each of these different lenses here, we have another level of magnification. So this lens will magnify things by 20, this one just by 4, and this one by 10. So to get the overall magnification, you need to multiply this number by whatever lens you're using down here. So on the lowest level for this microscope, it's 4 by 10. So if I'm to look at something down here right now, I'm only seeing it 40 times bigger than what it normally is. But whereas if I turn it to, say, the 20, then that's 20 times 10. I get to see it 200 times bigger than what it normally is. Cool. So that's how you can calculate magnification. Now, we also measure things in micrometers usually. Get even smaller and use nanometers, but micrometers are measured, written like this, with a really funny Greek U symbol. So that's how you measure a micrometer. One micrometer is 1/1000th of a millimeter, just like how a millimeter is 1/1000th of a meter. Okay. So here are microscopic scales again, and here's a whole set of different objects that are on different sizes of microscopic scales. So we got different cells, as we see down here, are getting between 10 and 100 micrometers in width. And then as the smaller we go, the smaller things we get bacteria that are even smaller. They're just like 1 micrometer in width. We also get visible light, which is like a little bit smaller than 1 micrometer, and then we get viruses. So here's the question: if a virus is actually smaller than what light is, so remember, light is basically just like a little wave or particle. If a virus is smaller than that light, how is it that we can actually see viruses under a microscope? Like, it's smaller than light itself. So when you've got something that is smaller than light itself, how can you see it? Because imagine this is little dot down here is the virus. Here's our particles of light. They bounce down, and it's like the virus is so small the light can't even pick it up. So the answer is we need to use instead of reflecting light off the virus, we have to reflect other things off the virus, specifically electrons. Electrons are even smaller than light, and they're actually parts of an atom. So that's why we need electron microscopes. The way an electron microscope works is instead of shooting light, like we do with just these microscopes, we've got light coming in. Instead of light, we see electrons being used. Because you're using electrons, you can produce images that are way, way more detailed on such a small level. Now, there are 2 types of electron microscopes, and you do need to know these 2 types. The first type is called the transmission electron microscope. Now, this is where you have, I've got diagrams here. The difference between these 2 microscopes is where is the sample? Where is the specimen you're looking at? With a transmission electron microscope, this is where the screen is. This is where you're going to get the overall image in the end. And these are where the electrons are being shot out of. So the electrons are being shot out of here, and with a transmission electron microscope, it's like an X-ray. So therefore, the electrons get shot through the sample, and then they end up on the screen. And so then with a transmission electron microscope, you can see the inside of things. With a scanning electron microscope, it's not like an X-ray. You're not getting the electrons shot through a specimen. You're just seeing them land on the edge of a specimen, and then you're just detecting where they land on the edge. So that's the two different types. This type, they're just landing on the surface. This type, they're getting shot through. So we've got two images here. Which ones do we think were used for which microscopes? Have a think. Now, if one of them, this one acts like an X-ray. This one we're just seeing surfaces. All right, time's up. This one is used by the SEM, or the scanning electron microscope, while this one would have had to be used by the TEM, or transmission electron microscope. Another detail is the SEMs, you don't get color with them. You can't get color, which means often when you see pictures from an SEM, like we did with the microscope quiz before, you see people color in those pictures with fake colors. Yeah, here's an actual electron microscope. This is an actual scanning, an actual transmission electron microscope where the sample would be in the middle here. And here is an SEM where the sample would be down here, and we've got a detector on the side. Cool. All right. That is it. Hopefully by now, by the end of this lesson, I would like you guys to make sure you know the differences between these four types of microscopes we talked about. We got some, and also I would like you guys to eventually learn how you draw microscopic images, because there is a procedure to that as well. There's some questions on style that I'm going to get you guys to do. But for now, I'll see you guys later. Thanks.